We go. Now, 9.141. Vertices are 1, 4 and 1, negative 2. And then it says the distance from the center to the focus, C to focus, is equal to 2 square roots of 2. Now, while we're in class, I do not mind you taking your phone out and taking pictures and notes on the board while I'm teaching, all right? Because we got to get this information out there. So you might have a friend at home that says, I wish I knew how to work number 43. And they go, oh yeah, he worked out in our class. Let me send it to you and I'll show you how it looks, okay? So if there's ever something you want to take pictures of during class, just go right ahead. We're not going to limit our use of technology. All right. What I would do is I would do a little sketch. 1, 4. And that's is that a vertex or a focus? I said that was a vertex, okay. And then 1, negative 2, right here. Now, I've already told you what I really should do is go ahead and write my formula with my blanks.
Mr. Edwin,
Yes.
last question. So there's 4 vertices on the ellipse, right?
There's only 2 of them are vertices. They're the long ones.
You was right. Because I was like, because we graphed 4, but only the 2 ones are on the major axis, so those are the
That's it. The other 2, I don't even know if the other 2 have a special name. All right? They're just the ends of the little short axis. Yeah. They didn't. But the long axis has the vertices. The vertices and the foci are always on the long axis.
So if they give you vertices, you know that that's
the long one.
All right.
Yeah. And that's. Oh, don't feel bad. When I started teaching this 30 years ago, when I was in school, I could always draw the ellipse and label all the points. But I'll be honest, I didn't know what they were called. Nobody ever asked me. I need that point. I need that point. But it does help when you start applying this in the physics class to know what they're called.
So a circle has 4 vertices then, because they're all equal distance.
I guess you could say that. Mm-hmm. Matter of fact, on a circle, you could say it has vertices at every point. Because the amount it's turning.
A circle is an ellipse.
Okay, remember, the vertices, okay, here's how you think about a vertices to get the real concept. A vertices is where you would have to turn your car the most if you were following the road. See, when you look at your ellipse, if it's longer this way, if you were right here, would you have to be turning your car as much as you would if you were here? No. No. Yeah, vertices are always where you get the greatest change in direction. Yeah. Vertices are the greatest change in direction. And so it may sound a little silly, but if you're driving your car and that was the road you were following, where would you have to turn it the most? All right. So, if I wanted to work this problem, I would get the center. I think y'all know that, right? You get the center first. And how do you get the center? You use your midpoint. 1, comma, add them together and divide by 2. And you get 1, 1, 1. I already heard somebody say that under their mask. Now, does everybody agree I'm counting longer up and down? How far did I count right here? 3. And I can write 3 squared or I can write 9. Either way. I bet you had all that before you even started, before you asked the question. You're asking about the next part, aren't you? Yeah, that's the hard part. Actually all of it is. I mean, this is all higher level, serious math. We're doing the real stuff in here. But when you want to do this one, formula for center to foci distance, don't I? Okay. The center to the foci distance is equal to square root of big squared minus little squared. I got a question for you, and we're not going to go into a lot of detail about it, but could you take a guess on where all of this started from? Distance formula and Pythagorean theorem. That is the hypotenuse, and that's one of the legs of the triangle. All right? And I haven't shown you that yet, and I haven't drawn the picture for it, and I should, and I need to, but really, if you were to see it in geometry class, that's the hypotenuse, and that's one of the legs. And this distance is the other leg. Okay, we know the distance is 2 square roots of 2. And now we know what the big number squared is. The big number squared is how much? 9. And why do we know it's the big number? Because the big number is always the one that we counted squared on the long axis. Now, when you square both sides, you square this, you're going to square the 2 is 4. Square root of 2 squared is 2, so you're going to get 8. 8?
See, I thought you were supposed to take it off and use multiplier 2 times 2.
You got to square the whole thing. Okay? Let's write that. You have to square this one and this one, and then multiply them together. And 2 squared is 4, and that's 2, so you get 8. And I'll go ahead and tell you, did you know that 2 square roots of 2 equals square root of 8? Yeah, if you think about it, when you take the square root of 8, 8 is what? 4 times 2. Take the square root of the 4, get you this one. There's that one. So, yeah, you better get 8 when you square that.
Why don't math lie to us? Because we stayed up all night like debating if it was like 3 or 4.
Well,
So you square the 2, take the...
and the square root of
other one.
the square root of 2 squared is just 2. Got the square root of 5 squared is just... What are you playing with it, Arthur? And then you get equals 9 minus little squared. 1 equals little squared. And so 1 squared, 1, 1. You just put your little 1 right there. And the good news is, what you're doing now is you're brushing up on some of those algebra skills. Some of those little nitpicky bits that we forget. And that's good. All right. Mr. Evans is about, does that get you started? Does that help? That get you started? And look online, because I'm going to post these too. And if someone in one of my other classes asks for this one, I'm not going to work it. I'm going to tell them it's online, and I'll work a different one in the other classes.
All right.
And that way y'all get multiple ones work.